Greetings and welcome. This is Dr. BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we will be learning about the oscillation of spring and arrangement of springs. The course outcome of this topic is compute the time period and frequencies of simple, compound and torsional pendulums using the basics of free and forced vibrations. The topic covered would be oscillation of spring and arrangement of springs. Topic learning outcome is understand the concepts of free and forced vibrations with simple harmonic motion and apply them to field problems. First, let us see the oscillation of springs. Consider a vertical spring with upper end fixed and the load of weight W is attached to the lower end as shown in figure. This is the spring when nothing is attached to the spring, no weight is attached to the spring. This is the undeformed length of the spring. When weight is attached, what happens? Because of the weight, the spring gets elongated. And in third case, what we are doing, we are applying some force. We are applying some force and we are holding it, and we are applying some force and making the spring to elongate until X from the normal condition where the weight is being added here. So this is the consideration which we should see while doing the topic. So consider a vertical spring with upper end fixed and the load of the weight W is attached to the lower end as shown in figure. Let K be the stiffness of the spring as you are seeing in the figure, and delta X be the deflection because of weight W. When weight W is added to the spring, the deflection is happening as delta X without any external application of force. Only weight is added to the undeformed spring and it moves or deforms to a distance of delta X. From here, the W, weight W can be given as K into delta X. That means the stiffness into the length to which it has been deformed. Let the body be pulled a distance X below the equilibrium and released. Then the body will move towards equilibrium with an acceleration due to the tension in spring. Therefore, tension T is equal to K into delta X plus X. Now from the free body diagram, we can see minus mg minus ma plus T is equal to 0. Here, as you can observe, as this body has been released from the extended position, the acceleration will be acting towards this side. Hence, we can say that the inertia force, that is Ma, will be acting towards downside. And considering the sign conventions, we can write minus mg minus ma plus T is equal to 0. From this, we can write minus K into delta X, which is the value of mg which we have taken, minus ma plus K into delta X plus X is equal to 0. If we further simplify this, we can write K delta X plus Kx minus K delta X minus Ma is equal to 0. This will give Kx is equal to Ma. From this, we can write the acceleration A is equal to Kx by M. Now we know the time period T is equal to 2 pi under root displacement by acceleration. So we can write 2 pi under root displacement is X and the acceleration we have obtained as Kx by M. If we further simplify, you will be getting the value of time period of spring is T is equal to 2 pi under root M by K, where M is the mass that is being attached and K is the stiffness of the spring. Now let us see the different orientations or arrangements of the springs. The first case would be springs that are attached in series. Okay, series, nothing but springs are attached one after the other. In this also there will be two types. One is weight is attached after the springs in series or weight is attached in between the springs in series like this. Okay, so we need to identify these two cases and try to understand how the time period values can be taken. In case 1, load acting on springs is same. Okay, so the load that is being acted W on each the spring, that is both the springs, is same here. Total deflection is delta is equal to delta 1 plus delta 2, where delta 1 is the deflection of spring 1 and delta 2 is the deflection of spring 2. So the total deflection would be delta 1 plus delta 2. So from this we can write W by K is equal to W1 by K1 plus W2 by K2. Also, as W1 and W2 are same, that means W1 is the weight acted on spring 1 and W2 is weight acted on spring 2. Just now we have seen that weight is acting same on spring 1 and 2. That's why we can take W1 is equal to W2. Ultimately, we can get 1 by K is equal to 1 by K1 plus 1 by K2. So, we can write K is equal to K1 K2 by K1 plus K2. So, in time period equation, we have T is equal to 2 pi under root 2 pi under root M by K. So, in this, K is written as K1 K2 by K1 plus K2. Now, as in the second case, we can see that W1 is not equal to W2. That means the weight which is supported by spring 1 is not equal to the weight that is supported by spring 2. So, we can write the W is equal to W1 plus W2. Take it as equation 1. Also, the elongation of upper spring is equal to compression of lower spring. That means the deformation, the deflections are same here. So, we can say theta is equal to theta 1 is equal to theta 2. So, we can write from this W1 by K1 is equal to W2 by K2. If we simplify this further, W2 is equal to W1 into K2 by K1. Now, substituting in equation 1, we can get the value as K delta is equal to K1 delta 1 plus K2 delta 2. Further simplification, we will get K delta is equal to K1 delta 1 plus W1 K2 K1. So, this can be written as K delta is equal to K1 delta 1 plus K1 delta 1 K2 by K1. So, from this we can write K is equal to K1 plus K2. And this K value can be kept in the equation of time period. T is equal to 2 pi under root M by K. Now, springs arranged in parallel. When the springs are arranged in parallel, it looks like this. And in this case, weight supported by each spring is different, but the extension of springs is same here. So, we can write W is equal to W1 plus W2. So, from this we can write K delta is equal to K1 delta 1 plus K2 delta 2. And from this K is equal to K1 plus K2, since delta 1 is equal to delta 2. And the time period can be written as T is equal to 2 pi under root M by K. So, in place of K, we can write K1 plus K2. This is how the arrangements of springs will be given. This concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.